Yes. Good morning, children. Welcome back. Yesterday we have learned about polynomials and its introduction. Today we will try to continue the rest of the topics. So before going to start with this polynomials session 2, let us recapitulate what we have learned yesterday. So what are the yesterday's topics we have learned about? General form of the polynomial and degree of the polynomial, basing on the degree, classifications of the polynomials. So when we discussed about classification of the polynomials, we have discussed about linear polynomial, quadratic polynomial, cubic polynomial and biquadratic polynomial. In all these things, now we'll look only to the quadratic polynomials, where we will be working only with quadratic polynomials. So let us directly start with quadratic polynomials. So for quadratic polynomials, you will be having three different types of questionnaires. So the first one, we will just try to make a flowchart what we are going to get from this. The first one, we have to find zeros of the quadratic polynomial. To find zeros of quadratic polynomial. And the second one, as already yesterday we have discussed, like what, for a quadratic polynomial, it have maximum two zeros. So to verify the relationship between zeros and the coefficients of the polynomial, relation between zeros and coefficients. And the last one is questions based on this zeros. What do we call two zeros of the quadratic polynomial? They are alpha and the other one as beta. So we call the third set as questions based on alpha and questions based on alpha and beta. So what are the three different sets we are going to have to find zeros of the quadratic polynomial, relation between zeros and coefficients of the polynomial, and questions based on alpha and beta. So in this relation between zeros and coefficients, again we have two different things. What is the two different things? One might be they will ask you to verify the relation. To verify the relation. Or the second one will be to frame a quadratic polynomial. What is the second one? To frame a quadratic polynomial. So again, coming from this, to frame a quadratic polynomial, there will be two different sets. In the first set, they may give you zeros. When zeros are given, or else when sum and product of zeros are given. Okay. So what is this? In the relation between zeros and coefficients, again we have two different types. The first one is to verify the relation, and the second one is to frame a quadratic polynomial or to construct a quadratic polynomial. Again, in this to frame a quadratic polynomial, there are two types. If alpha and beta, that is nothing but if the zeros are given, how to frame a quadratic polynomial, or in case if the sum of the zeros and product of the zeros are given, how to frame a quadratic polynomial. Am I all clear with the flowchart, children? Once verify. For a quadratic polynomial, there will be three different types. What are the three different types? To calculate or to find the zeros of the quadratic polynomial, relation between zeros and coefficients, and questions based on alpha and beta. So again in this relation we have two types, to verify the relation or to frame a quadratic polynomial. Coming to frame a quadratic polynomial, if zeros are given, how to frame? And if sum and product of the zeros are given, how to frame? So let us start with the first step. What is the first step here? To find zeros of a quadratic polynomial. So to find zeros of a quadratic polynomial. So let us take first one. P of x is equals to x square plus 5x plus 6. What is the first one? X square plus 5x plus 6. So how do we do? 1 into 6. 6. Factors for 6 are 1 into 6 and 2 into 3. Since b is positive and c is also positive, we go for the factors 2 plus 3 is equals to 5. So therefore 5x is split into 2x plus 3x plus 6. From this to what is common? X is common. Then x plus 2. From this to 3 is common. So I will take x plus 2. So overall x plus 2 is common. And then what you are going to get? X plus 3. So to find zeros, p of x must be equals to 0. That means x plus 2 is equals to 0 and x plus 3 is also equals to 0. If x plus 2 is equals to 0, x is equals to minus 2, x is equals to minus 3. Therefore, what are the zeros for this polynomial? Therefore, minus 2 comma minus 3 are the zeros of p of x. So what is that? As the given p of x is x square plus 5x plus 6, we'll try to write the factors for 6. 1 into 6 and 2 into 3. Since everything is positive, what we will do? We will go for factors where they adds up to 5. So 2 plus 3 is equals to 5. So let us split 5x as 2x plus 3x. And from the first set, I can take x as common. So I am going to get x plus 2. And from the second set, 3 is common. Therefore, x plus 2. Overall, x plus 2 is common and then x plus 3. So to find zeros, p of x must be equals to 0. So x plus 2 is equals to 0 or x plus 3 is equals to 0. X is equals to minus 2, x is equals to minus 3. So the two zeros are what? Minus 2 and minus 3 are the zeros of the p of x. Let us go for one more problem. Now we will take P of y. P of y is equals to y square minus 6y plus 9. So when P of y means it's a polynomial in the variable y. 1 into 9 is 9. Factors for 9 are 1 9s are 3 3s are. Again, if you see, the product is positive and the sum is negative here. Therefore, we goes for 3 plus 3, that is equals to 6. So how do we write? 6y is split into minus 3y plus 9. From the first set, y being the common, y minus 3. From the second step, minus 3 being the common, again y minus 3. Overall y minus 3 is common, and here also again y minus 3. So what do we write? Y minus 3 is equals to 0. Again, this is also y minus 3 is equals to 0. So y is equals to 3, y is equals to 3. So here the two zeros are same. What are the two zeros? Only one zero, that is 3. Here also it is 3, here also it is 3. Therefore, 3 is the zero of P of y. Yesterday when we are looking at the graphs, we have observed a graph where the parabola touches x-axis only at one point, and we were already discussing about that. If it touches only at one point, it indicates what? It will have only one zero, and that is equal zeros. So alpha is equals to 3 here, beta is also equals to 3. Whereas in this case, alpha and beta are different. Alpha is minus 2, beta is minus 3. But in the second example, what we have seen, alpha and beta are same, and that is nothing but equal values. Let us move with some more problems. Third one. Already as we are discussing with EG numbers, let me just go for some more root values so that you can complete your other problems. Before I move with root problems, let me give you some sort of homework where you can work only to find the zeros of a quadratic polynomial. Please make sure that you copy these problems and try to find the zeros of that quadratic polynomial. The first one is x square minus 2x minus 8, and the second one is 4s square minus 4s minus 1. Sorry, this is plus 1. 4x square minus 3x plus 1. 3x square minus x minus 4. Okay. So for these four problems, what you are going to do? Please try to find the zeros of this quadratic polynomial. Once you are done with now finding zeros of the quadratic polynomial, then we will move on to the relation between zeros and the coefficients. So one more problem I will tell you. Root 2x square plus 7x plus 5 root 2. So this is equal to P of x. So now here the product must be root 2 into 5 root 2. What you are going to get root 2 into 5 root 2 when you multiply? Root 2 into root 2 is 2. 2 into 5 is 10. So factors for 10, 1 tens and 2 fives. Since all are plus, we goes for a factors where they accept 2 to get 7. So 2 plus 5 is equals to 7. Root 2 x square plus 2x plus 5x plus 5 root 2. So in the first set, what is common? Though we may see only x, but root 2 is also common because 2 can be written as root 2 into root 2. So can I take root 2 and x as common here? When I take root 2 and x is the only element left over here. When root 2 is taken out, x is also taken out. Therefore, the leftover element is root 2 plus what is common here? 5 x plus root 2. Overall, x plus root 2 taken common. Then what you will get here? Root 2x plus 5. So, p of x is equals to 0. That implies x plus root 2 is equals to 0. That is x is equals to minus root 2. And the other one is root 2x plus 5 is equals to 0. That implies root 2 into x is equals to minus 5. X is equals to minus 5 by root 2. So what are the zeros over here? Minus root 2 comma minus 5 by root 2 are the zeros of p of x. So how many zeros we have got? One is minus root 2 and the other one is what? Minus 5 by root 2. So please be careful when you are working with root values especially. So root 2 into 5 root 2 is equals to what is that? First you multiply the root numbers. Root 2 into root 2 gives you 2. 2 into 5, 10. For 10 the factors are 1 into 10 or it might be 2 into 5. Since 2 5s are 10, we are taking 7 as 2 plus 5. Take 2 plus 5 and here this 2 can be again rewritten as root 2 into root 2. So what is the common element? Root 2 common and x also being common. When you take root 2 and x as common, x is the only variable left over here plus root 2 is only left over here. So x plus root 2 here and here if you take 5 common, x plus root 2. Overall x plus root 2 is common, root 2x plus 5. Since p of x must be equal to 0, this is equals to 0 and this is also equals to 0. From there we are getting x is equals to minus root 2 and x is equals to minus 5 by root 2 are the two zeros of p of x. Yes, can I move with one more square roots problem? So this is the fourth problem. P of x is equals to root 3x square minus root 3x square minus 8x plus 4 root 3. Okay, same like previous problem. So how to start, children? Multiply this coefficient and the constant. Root 3 into 4 root 3. When you multiply root 3 into 4 root 3, please try to multiply first root 3 values. Root 3 into root 3 gives you 3. 3 into 4 is equals to 12. So, for 12 factors, 1 12 are 12, 2 6 are 12 and 3 4s are 12. So, here if you observe, product is positive and sum is negative. So, if the sum is negative, we should go for addition of the factors. Which two factors adds up to 8? So 2 plus 6 is equals to 8, and let us go with this 2 and 6. Root 3x square minus 6x minus 2x plus 4 root 3. What can I take common here? Again, if you observe, this 6 can be written as 3 into 2. Again, 3 can be written as root 3 into root 3. So, overall, if you see, root 3 is common in this side and in this side also. So, take root 3 and x. When I take root 3 and x out, only x left over here, x minus root 3 is taken. So, what is left over? 2 root 3 x minus 2 root 3, and from this what can I take common here, children? 2 minus 2, if I take minus 2 common, x minus 2 root 3. So overall x minus 2 root 3 is common, then root 3x minus 2. So to get zeros, what will we do? X minus 2 root 3 is equals to 0. That implies x is equals to plus 2 root 3. Root 3x minus 2 is equals to 0. That implies root 3x is equal to 2. X is equals to 2 by root 3. So what are the two zeros? X is equals to 2 root 3. X is equals to 2 by root 3. So how can I conclude here? 2 root 3 and 2 by root 3 are zeros of P of x. Is the problem clear, children? Root 3 into 4 root 3. So root 3 into 4 root 3 means, how do we take it? Root 3 into root 3 is 3, and again 3 into 4 is equals to 12. So factors for 12 are 1 12 and 2 6 and 3 4. As only the sum is negative and product is positive, we goes for addition of the factors. So when I am checking for the addition of the factors, 2 and 6 adds up to 8. Therefore, minus 8 I will write it as what? Root 3x square minus 6x minus 2x plus 4 root 3. See here, you may have a doubt why teacher have taken instead of 2x minus 6x. Teacher has taken 6x minus 2x minus 6x minus 2x. If I take 2 over here, there will be no common element between root 3 and 2 except the variable x. Therefore, better try to write 6 over here and 2 over here, because as per the commutative property, you can add the two numbers in any way. Yes? Can I quickly move on to the second topic called as relation of zeros and the coefficients of the polynomial. Okay. Relation between zeros and coefficients of the relation between zeros and coefficients of p of x. Okay. So when we are going for to identify the relation, let us take a polynomial first and we will find the zeros of the polynomial. And then we will see once after we get the zeros, let us name the zeros as alpha and beta, and then we will go for how it is related to the coefficients. So for that, let me take an equation polynomial. P of x is equals to 6x square minus 7x minus 3. Okay. So, how do we split the middle term to find zeros? 6 3 is 18. Factors for 18. 1 into 18. 2 into 9. 3 into 6. Okay. Now, if you see, sum is negative and the product is also negative. When sum and product are negative, we should go for difference of the factors. That is 9 minus 2 is equals to 7. Do we need 7 or minus 7? Minus 7. Therefore, it will be what? 2 minus 9. 6x square plus 2x minus 9x minus 3. So, from the first set, what is common? 2x, 3x plus 1. What is common here? Minus 3, 3x plus 1. So, overall 3x plus 1 is common and 2x minus 3. So, this must be equal to 0. So, if 3x plus 1 is equals to 0, what are you going to get? X is equals to minus 1 by 3. So, this one we call it as what? Alpha. And the second 0, 2x minus 3 is equals to 0. That implies x is equals to 3 by 2. That is beta. Children, here I skip the step. 2x is equals to 3 and then since it is multiplying 2 goes that's a division. So x is equals to 3 by 2, x is equals to minus 1 by 3. Alpha is 1 minus 1 by 3 and beta is 3 by 2. So, minus 1 by 3 comma 3 by 2 are zeros of P of x. That implies what did we put? Alpha is equals to minus 1 by 3, beta is equals to 3 by 2. Okay. Zeros we have got. Now what are we supposed to verify here? Relation between zeros and the coefficients of P of x. So as and when I have got the zeros, let me add the zeros. So addition of zeros we call it as what? Sum of the zeros. Sum of zeros. What are the two zeros here? Alpha and beta. That is alpha plus beta. Try to add alpha plus beta. Minus 1 by 3 plus 3 by 2. When you are adding, please take the LCM. LCM for 3 and 2 is 6. As 3 and 2 are co-primes, we can directly multiply and put the value at 6. 3 2 therefore it is minus 2. 2 3 3 3 there is 9. So what you are going to get? 9 minus 2 is 7 by 6. So finally what we got? Alpha plus beta is equal to 7 by 6. We will put this aside. After sum of zeros, we will go for product of zeros. Product of zeros. Product means alpha should be multiplied with beta. Alpha into beta. Minus 1 by 3 into 3 by 2. Cancel. So alpha beta is equals to what is that? Minus 1 by 2. So this also we'll put like this. Now we got zeros and we'll verify with the coefficients of the P of x. Only we'll put the P of x. Let us solve the probability. Okay. From this polynomial, what is your standard form of quadratic polynomial is in the form of what is that? Ax square plus bx plus c. So we'll compare with the standard form. A is equals to here. A is equals to 6. B is equals to minus 7 and C is equals to minus 3. Okay. So now we'll see alpha plus beta is equals to 7 by 6. So relation means when we are going for the relation, if you observe alpha plus beta value, what did we get? 7 by 6. Can we see 7 over here in the place of B and 6 in the place of A? So we'll try to calculate minus B by A. That is equals to what? Minus of minus 7 by 6. That is equals to 7 by 6, which in terms is equals to what? Alpha plus beta. So alpha plus beta is equals to minus b by a is verified. Yesterday we already have discussed alpha plus beta, that is sum of the zeros should be equals to what? Minus b by a is verified. Now the last one is what? Alpha into beta, that is product of the zeros. Alpha into beta. Before going for alpha into beta, we'll see where can we see these values. What is here? Without cancelling, what we get is minus 3 by 6. Where can I see minus 3? In the place of constant and 6 in the place of a. So, I'll try to calculate first c by a. C means what? Constant. Constant is minus 3 by and a is 6. 3 ones are 3 twos are. That is equals to what? Minus 1 by 2. And this C by A is also equals to alpha into beta. So therefore what can we conclude? Alpha beta is equals to C by A is also verified. Okay. So after finding zeros, what is the next step to do? Please go for the sum of zeros, that is nothing but alpha and beta. Add alpha and beta so that you get a value, and this alpha plus beta must be equal to what? Minus b by a. And after alpha plus beta, please go for product of zeros, that is alpha into beta. When you multiply alpha into beta, you are going to get the same value as c by a, where constant by coefficient of x square. This is nothing but verification of zeros and coefficients of the polynomials. Shall we go for one more problem here? Okay. Let's just take p of x is equal to 5x square plus 12x plus 7. So 5 into 7, that is equals to 35. Factors for 35, 1 into 35 and 5 into 7. Since product is positive and sum is positive, we go for the factors which adds up to 12. 5 plus 7 is 12. So 5x square plus 5x plus 7x plus 7. What can I take common? 5x take it common. X plus 1 plus 7 being the common element. X plus 1 once again. Overall x plus 1 is common. And then what we are going to get? 5x plus 7. To find zeros, we will equate it to 0. X plus 1 is equals to 0. That implies x is equals to minus 1, which we also call it as alpha. 5x plus 7 is also equals to 0. That implies x is equals to minus 7 by 5. And in terms we call it as beta. So after getting alpha and beta, what is our condition to do? Relation between these zeros. So that is sum of zeros. The sum of zeros is equals to what? Minus 1. Let me write alpha plus beta, that is equals to minus 1 plus minus 7 by 5. Take LCM. What are you going to get? minus 5 minus 7 by 5. That is equals to minus 12 by 5. So as already we have got, where can we see minus 12 in this P of x? It is minus of B. And where do we see this 5? In the place of A. So minus 12 by 5, that is alpha plus beta is equals to minus B by E. That is equals to what? Minus 12 by 5 is verified. And then the next one is product of zeros. When I go for product of zeros, multiply alpha into beta, that is equals to minus 1 into minus 7 by 5. Minus into minus plus, so that is equals to 7 by 5. Where can you see 7? In the place of constant, and 5 in the place of coefficient of x square. So this is equals to, what can I say? Constant by a. So alpha beta is equals to c by a is equals to, what is that? 7 by 5 is also verified. Am I all clear, children, here? First, what are we going to calculate? As and when we get the two zeros alpha and beta, please go for the sum of the zeros and try to add. And this value always must be equals to, what is that in the coefficients? Minus b by a. And after that, go for the product of the zeros. And product of the zeros must be equal to what? The ratio of, that is constant divided by coefficient of x square. That is alpha beta is equals to c by a. After that, alpha beta and alpha plus beta, you just write alpha plus beta is equals to minus b by e. Alpha beta is equals to c by a is verified. So, please kindly remember, as in the initial state only, I gave you this problem as homework to find the zeros. After finding the zeros, please continue to verify the relation between zeros and the coefficients of p of x. Yes, children, please find zeros first, and then what will you do? Verify the relation between the zeros and the coefficients of this polynomials also. So, in the next topic, after relation, what we are going? In the relation, again, there are two types we have discussed. What are the two types in the relation? One is to verify. So, till now we were doing that only to verify the relationship. And the next one is what actually? To frame a quadratic polynomial if zeros are given and if sum and product of zeros are given. Try to recollect reminder theorem and factor theorem of your class 9 to frame a quadratic polynomial. Okay. So in this again, to frame a quadratic polynomial, we have got two cases. What are the two cases here we have described? One is when zeros are given. Zeros are given in the sense, what are the zeros given? Alpha and beta. And the second one, what is that? When sum of zeros and product of zeros are given. Sum of zeros and product of zeros are given. So, before going into this, we will try to recollect reminder theorem and factor theorem of your class 10. So, suppose in case for a p of x, 5 is the remainder means, in factor theorem, how do we write it as? If, let us see, if 5 is in 0 of x plus 5 means, how will you write it? Can you all remember, children? Do you all remember? Or else, in case let me take this little bigger value so that you can easily see. x square minus 4x plus 4. So, we used to substitute 2 in place of x. But in factor theorem, what we will write? X minus 2 is a factor. Aren't we? If 2 is a 0, how to write x minus 2 is a factor. Similarly, here also, we are going to find the zeros. What are the two zeros we are going to calculate for quadratic polynomial? Alpha and beta. So, to get a polynomial also, if alpha comma beta are zeros of p of x, that implies required p of x will be in the form of required p of x is equals to x minus alpha into x minus beta multiply x into x square minus beta x minus alpha x plus alpha beta. Here, if I take common minus x, what am I going to get? Alpha plus beta plus alpha beta. So, this is the equation or this is the expression to find a quadratic polynomial when two zeros are given or when sum of the zeros and product of the zeros are also given. What is that? X square minus x into alpha plus beta plus alpha beta. You also can write this without any confusion, x square minus x. Alpha plus beta means what is that? Sum of zeros. You indicate it with capital S, sum of the zeros into x plus alpha beta is nothing but what is it? Product of the zeros. You indicate it with capital B. So how do we write? X square minus sum of the zeros into x plus product of the zeros. Am I all clear? How do we write it? X square minus sum of the zeros into x plus product of the zeros. Let us take examples for when zeros are given and when sum and product are given also. So the first one I am taking when zeros are given. When zeros are given. Okay. So alpha is equals to 5, beta is equals to minus 3. So alpha is a 0, beta is also a 0. What are the two zeros given? 5 and minus 3. So when zeros are given, first you calculate alpha plus beta, that is sum of the zeros. 5 plus minus 3. What are you going to get? 5 plus minus 3 is 2. And then immediately you also calculate alpha beta 5 into minus 3. That is equals to what? Minus 15. So, to frame a quadratic polynomial, required p of x is in the form of, we already have learned x square minus alpha plus beta into x plus alpha beta. So, in place of alpha plus beta, what shall I write? 2. X square minus 2x. In place of alpha beta, what should I write? Minus 15 is the required p of x. Is this clear, children? If alpha and beta, that is nothing but zeros are given, what are we supposed to do? Sum of the zeros and then product of the zeros. After writing, please go for your general form, that is x square minus. Also, we have learned it as sum of zeros into x plus product of zeros. In the place of sum, directly you put your 2, and in the place of product, please replace with product. Therefore, x square minus 2x minus 15 is required p of x. Now, we will go for when sum of zeros and product of zeros is given. We will be using the same formula. Only thing is that here they will be giving you instead of zeros, sum of zeros and product of zeros. So question will be like this further. Find a quadratic polynomial whose sum and product of zeros are given as 7 and minus 12. 7 and minus 12. So here you should understand whether this 7 and minus 12 are zeros or sum and product of the zeros. So here they are clearly talking about sum and product of zeros. So the first one we call it as sum of the zeros and second one we call it as product of the zeros. So we will write sum of zeros. Sum of zeros means how do we write it as alpha plus beta is given as 7. Product of zeros. Product of zeros means what is that? Alpha into beta, that is given as minus 12. So, what is the required P of x? Required P of x is equals to x square minus x into alpha plus beta plus alpha beta. So, x square minus, what did we get alpha plus beta as? 7. So, minus 7x. What did we get alpha beta as? Minus 12 is the required P of x. So what is this? When they give you sum and product, directly we will write sum of zeros as alpha plus beta, that is equals to 7. And when they give you product of zeros, what will we write? Alpha into beta is equals to minus 12. And let us go for required P of x, that is equals to x square minus x into alpha plus beta plus alpha beta. Simply we replace the sum of the zeros with 7 and this product of the zeros with minus 12. So x square minus 7x minus 12 is the required P of x. So hope we completed what we have written. What is that? In the session 2 what we planned for to verify the relationship between zeros and coefficients of the polynomial, to find the zeros of the polynomial, and to frame a quadratic polynomial when zeros are given and when sum and product of zeros are also given. And the last one, questions based on alpha and beta. Tomorrow we will complete questions based on alpha and beta and division algorithm of polynomials. And please don't forget these problems, for these 4 problems you are expected to do to calculate zeros of the polynomial and also to verify the relation between zeros and the coefficients of the polynomial. Okay children, fine. Please complete your work and notes will be forwarded to you also. Make sure that you complete all the work given to you and let me know if you have any queries. Thank you so much.